Hi guys, Mrs. Thompson here, and today we're going to start learning how to do stoichiometry problems. Now the word stoichiometry, kind of hard to say, but it's not too hard to do. That first part, stoich, is just a German word for atoms, and then metry just means measure. So this is like the measure of atoms. It's going to incorporate the things that we learned last semester with balancing equations and the mole. Okay, and so here is a little ChemCat humor. What is a chemist's favorite plant? A stoichiometry. Alright, so here's what stoichiometry is. It's the ability to convert from one substance to another within a balanced equation by using the mole ratio. Okay, we should have gone over mole ratio already, but here we go. Here's what it is. It's a conversion that goes from mole to mole. Okay. And how we get the mole ratio is we use the coefficients in a balanced chemical equation. So you have to absolutely have a chemical reaction in order to do any stoichiometry problem. Yay, stoichiometry. Okay, this is our general setup. It's basically our roadmap to figure out how to solve these problems. It goes in this order: G, M, N, G. Grams, moles, grams. You have A and B here. That's just because we're changing the substance. And so A is just going to represent the one that we have given, the one that we have the number for, and the one that we're going to change. Okay? And then B just represents the unknown substance, the new substance that we're trying to find. All right, so for the first step, to go from grams to moles, all you have to do is use the molar mass. Now we used this in the last unit. The molar mass is just how many grams per mole. Okay, you can look that up on the periodic table and then add up however many atoms you have and which atom you have and all of that good stuff. Here we go. So a couple things to note. One always goes with the mole. You never put any other number in front of here when setting up a conversion factor. Okay, it's always a 1. Then the other thing we need to know is that the number of grams are coming from the formula. So we look at the formula, we add up however many sodium atoms or calcium atoms, hydrogen, we look that up in the periodic table, add them all up. It has nothing to do with the number that's in front of the given. It has nothing to do with the balanced equation. It's just simply from the formula. Okay. Next step is the mole ratio. This is something new. We're going from number of moles of unknown, or excuse me, from given to unknown. And so to set this up, you put the unknown on the top and the given on the bottom, so you can cancel out the given. The numbers that are in front are coming from the balanced chemical equation. So you absolutely have to have that reaction to solve this, and it has to be balanced. And then this step here is the molar mass. So to go from moles of B to grams of B, this is a new substance, you're going to use the molar mass. And notice I've written it a little bit differently than I did in the first step. In the first step, we were trying to cancel out grams, so grams is on the bottom. In this step, we're trying to find grams, so grams are on the top. So here's the process we're going to use. We're going to start with a balanced equation. If it's not given to you, you'll have to write it, or if they give you a skeleton equation and you have to balance it, do that first. Then you're going to read the problem, of course, and then figure out the following 3 things before you start. That is, figure out what the given is, figure out what the unknown is, and figure out how many steps you need to take. So we're going to remember G, M, N, G and kind of figure out how many steps. And then you can solve. Okay, first problem. How many moles of aluminum are needed to form 2.3 moles of aluminum oxide? We have a skeleton equation that needs to be balanced. Let's go ahead and do that. I've got 2 oxygens on the left and 3 on the right. So I need a number that both 2 and 3 will go into, and that is 6. So I'm going to put a 3 in front of this oxygen, which gives me 3 times 2, 6 oxygens on the left, and then a 2 in front of this one, which gives me 2 times 3, which is 6 oxygens on the right. Now I've changed the number of aluminums. It's 2 times 2, so that's 4. So we need a 4 over here. So if you remember how to balance, great. If not, you need to review that. All right, we have the mole map here that you already have drawn. So we're just going to refer back to this. Our next step is to identify the given, the unknown, and the number of steps that we're going to need. So for the given, it's the number and all of its units, 2.3 moles of aluminum oxide. and the unknown is the number of moles of aluminum. Okay, so this is how many moles. The number of steps we're going to determine by just kind of writing out GMMG. Okay, gram, mole, mole, gram. And then I'm going to split this up because half of this belongs to the given and half of it belongs to the unknown. So the left half is the given, which is in terms of aluminum oxide. The other half is in terms of aluminum, the unknown, what we're trying to find. So it would be grams of aluminum oxide, moles of aluminum oxide, and then on the right side, moles of aluminum, grams of aluminum. Okay. So we'll start with our given. Stoichiometry. What I did here was I just canceled out the gram. Why did I cancel out gram? Well, in the problem it says we're going from moles of aluminum oxide. So we just need the M in the GMMG part, or the GM on the left. And then on the right side, I want to get to moles. And so we're going to cancel out this gram because we don't need it. We just have a one-step problem going from moles of aluminum oxide to moles of aluminum. Okay, start with the given, which is 2.3 moles of aluminum oxide. Multiply that times. So to go from mole to mole, what do you need? Well, according to the map here, we need a mole ratio. You notice down here, there it is. Go from moles of A to moles of B. We need the mole ratio, and that's always the number of moles of unknown divided by the number of moles of given. So let's see. This is the time where we're going to use the balanced chemical equation. So let's use it. Moles of given. So the given is in terms of aluminum oxide. So if I look up here, we have 2 moles of aluminum oxide according to this balanced equation. So we'll put that down there. And then number of moles of the unknown, well, the unknown is in terms of aluminum. So according to the balanced equation, we have 4 moles of aluminum for every 2 moles of aluminum oxide. Okay, this is the only time where you get to use those coefficients is when you have mole over mole. All right. So now we'll cancel out our units. Not only does mole cancel, but aluminum oxide cancels. I've changed it from aluminum oxide to aluminum by using the balanced equation. All right, then I'm going to do the math. It's multiply the numbers across the top, divide by the numbers on bottom. So it's 2.3 times 4 divided by 2. Practice plugging these in. And in your calculator, you should get 4.6 moles of aluminum. All right, so now we just have to worry about finishing this problem by looking at the number of significant figures. So 2.3 has 2 sig figs, and 4 and 2, well, you'd think that you just have 1 significant figure, but this is a conversion factor. It's kind of like a definition. We know that for every 2 moles of aluminum oxide, there's going to be 4 moles of aluminum according to that balanced equation. So we say this has an unlimited number of significant figures. So we'll just limit it by the 2, the least number of sig figs. So 4.6 has 2, so that's my answer. Right, so this is a quick problem, a mole-to-mole problem. One-step problem. It's really important that you know where you're starting and where you're heading so that you don't overwork the problem. You don't change it from moles then to grams when you only needed moles. All right, next one. Calculate the mass of magnesium oxide produced from the reaction of 2.5 moles of magnesium and excess oxygen. All right, notice I'm not given the balanced equation. So I'm going to have to make that equation and then balance it. Done, right? All right, so here we go. We've got magnesium oxide produced, so that's going to be on the right side of the arrow. And then we've got magnesium and excess oxygen in the reaction, so that's going to be on the left. So it's going to be magnesium plus oxygen, the 2 reactants. Oxygen is not just O, it's O2. And then it's turning into magnesium oxide. Now, they gave me the formula for magnesium oxide, but if you had to come up with it, you had to go back to charges. You had to say, okay, magnesium's 2 plus, oxygen's 2 minus. We need 1 of each of those. All right. So then, balancing it out, we have 2 oxygens on the left, so we need 2 on the right, which also changes the number of magnesiums, so we need a 2 in front there. All right, now we need the given, the unknown, and the number of steps. So the given is 2.5 moles magnesium. The unknown is calculate the mass of magnesium oxide. So mass is grams. We want the number of grams of magnesium oxide. There's also some information about oxygen this time. So what do we do with that? Well, we're just going to cross that out. This means we have plenty of oxygen. It's not going to limit the amount of magnesium oxide that's produced. The thing that will do that will be the moles of magnesium. So we'll just cross out oxygen after we've got our balanced equation. We don't really need that information. Okay. So then we've got our steps, GMMG. All right, so remember that half of this belongs to the given, half of it belongs to the unknown. So on the given side, we have magnesium. On the unknown side, we have magnesium oxide. All right, so let's see, how many steps will that require? Well, I'm going from moles to grams. So I'm going from mole to gram. So I'm going to get rid of this gram because I'm starting with mole. Okay, so what steps are going to be involved? Well, if you look at this map here, starting, I don't need this step. It's crossed out. I need the mole ratio, and I also need the molar mass. Okay, so 2.50 moles of magnesium is my given. That's where I'm starting. I multiply it times the mole ratio. Anytime you start with mole, really, that's the first step. Use your mole ratio from the balanced equation. All right, so mole ratio is number of moles given on the bottom, and it's magnesium. So there's 2 in front, so it's going to be 2 moles of magnesium on bottom. And then number of moles of unknown on the top, that's magnesium oxide. So 2 moles of magnesium oxide on the top. Moles of magnesium cancel. And if I was just going from mole to mole, I'd be finished. But actually I'm going from mole to mole to gram. So I need this step, the molar mass step. All right, so molar mass. Well, that's going to be the number of grams on top and the 1 mole on the bottom. So we'll put 1 mole of magnesium oxide on the bottom. Oh, so let's figure out what the molar mass of magnesium oxide is. Remember, we do that by looking at the periodic table. I look at magnesium. I have 1 of them. It's 24.31 grams. So 1 times 24.31 is just 24.31. For oxygen, I have 1 oxygen. It's 1 times 16, which is just 16. Notice I carried over the 0, 0, just so I can add them and have 2 places past the decimal. And so when I do that, it becomes 40.31 grams. So in every 1 mole of magnesium oxide, there are 40.31 grams of magnesium. Notice I'm doing that for 1 mole and 1 mole only. I'm not concerned with the coefficient. I've taken care of the coefficient part in this step right here, in the mole ratio. Okay. So magnesium oxide cancels, and then I just do the math. Okay, there's lots of ways to do this. One easier way is just multiply and then divide. Multiply and then divide. Or you can multiply across the top, put it in parentheses in your calculator, hit divide, multiply across the bottom, and then hit enter. Actually, I like to put the bottom in parentheses too. Alright, well, practice doing that. I get 100.775, so that's what you should have gotten. And now I just have to check for sig figs. 3 sig figs in this number, in unlimited in the mole ratio. In this molar mass I have 4, and so 3 is the least number of sig figs, so I'm going to chop it up right here. 7 is going to bump up to 0, and I get 101 grams of magnesium oxide. Alright, hopefully that's easy. Last example, calculate the number of moles of water produced when 8.08 grams of hydrogen reacts with an excess of oxygen. I'd like you to come up with a balanced equation, so pause it. Okay, so hopefully you got this. If you didn't, remember that hydrogen and oxygen are diatomic. Remember they are in the mnemonic Brinkelhoff, so remember those are always good too. Okay, so let's figure out the given, the unknown, and the steps. So the given is the number in its unit, 8.08 grams of hydrogen. The unknown, it says the number of moles of water. So we're going to go question mark mole water. Perfect. And then we have that whole excess again. So just cross that out. We don't need that anymore after we've got the balanced equation. All right. And then the number of steps. Gram, mole, mole, gram. Remember that half of it belongs to the given hydrogen. The other half belongs to the unknown water. Okay. Let's see how many steps though. So we're starting with gram. So it's right here. We want to get to moles of water, not hydrogen, but water. So we're going to go to this one, which means we don't need that. So that's going to be 2 steps. One to go from gram to mole, then one to go from mole to mole. From gram to mole, we need, let's see right here, grams of A to moles of A, we need the molar mass. And then to get from hydrogen to water, we need the mole ratio. So we'll start with our given. It's 8.08 grams of hydrogen times, we need the molar mass. So the number of grams of hydrogen is going to go to the bottom. I got 2.02. How did I do that? Well, I've got 2 hydrogens. Each one is 1.01, so that's 2.02. And that's going to be equal to 1 mole of hydrogen. Remember, it's always equal to 1 mole when you're finding the molar mass. Don't look at that coefficient. Not yet. Okay, so that cancels out the grams of hydrogen. That means we went from here to here. Now we need the step with the mole ratio, going from moles of unknown and moles of given. So moles of given are going on the bottom. And so given is in terms of hydrogen. So hydrogen is a 2 in front, so that means we have 2 moles of hydrogen for every 2 moles of water. So moles of hydrogen cancel. We multiply across, divide by the numbers on bottom, and you get 4 moles of water in our calculator. Hopefully you see there's something wrong with this. Think about what this should be. We've got 3 sig figs here, and then 3 sig figs in the molar mass, and then unlimited sig figs in the mole ratio. So we need 3 sig figs, and this has only got 1. So we have to turn it into 3 sig figs. So that's going to be 4.00 moles of water. Okay, so hopefully you're getting the hang of this and you just have to do some practice.